Welcome everyone to our 2021 Tropical Weather Outlook. So this is a summer and tropical weather outlook. My name is Andrea Berg and I am a product marketing manager here at DTN. And I am joined today by our three long-range forecasters, forecast meteorologists, Jeff Johnson, Nathan Hamlin, and Stephen Strum. Plus, we also have our weather product managers, Wes Hyduke, Ryan Fulton, and Ben Hershey. I just want to go over some housekeeping before we begin. We are recording this session, and we will send out the recording after this session. Usually takes about 1 to 2 weeks. So please be patient and wait for it. We will send it out via email, and we will also post it on our website as well. Everybody is muted, but if you have any questions at any point during our presentation, please enter them on the right side of your screen in the Q&A portion of the screen. We will also do a short poll at the end of the long-range forecast before we enter the industry impact session. So please look for that, and we'll make an announcement when that poll goes live. So with that, I believe I got through all of the housekeeping. With that, I'm going to pass it over to, I believe it is Nathan. I could be wrong. It could be Jeff.
Yeah, thanks, Andrea.
Thanks,
This is Jeff. Hello, everybody, and welcome to our Tropical Outlook presentation. As Andrea mentioned, we do have several presenters here, the forecast team on the left and product management group on the right. We'll go into operational impacts and how to apply some of the information that we're trying to convey today. But as far as the flow of the presentation, we're going to look back at 2020, cover some of the tropical season highlights, and then look at the next several months and what type of seasonal influences we expect for the 2021 tropical season. We'll look at a few of the computer models to see what they are giving us in terms of guidance, put it all together into our tropical season forecast, and then also some summer season weather highlights for the United States. And then, as I mentioned, we'll turn it over to our product management team to go over some industry specific insights. And at the end, we have reserved time for some questions. So beginning with a recap of 2020, pretty much a nightmare for a good part of the country. We had a record-breaking year. 30 named storms occurred. That was about double what the average is. And we also had 14 hurricanes and seven major hurricanes. Those parameters also about double the average number. So quite an incredible year in the Atlantic Basin. And unfortunately, a lot of these storms did impact the United States. There were 12 named storms that made landfalls in the U.S., and 6 of those landfalls were hurricanes. That also broke a previous record extending way back to 1916. At that time, 9 named storms made landfall, so pretty historic. $51 billion in damage. It was the 6th year in a row before the season began that we had a named storm develop, and also the 5th year in a row that a Category 5 storm produced in the Atlantic Ocean. So an incredible year for 2020. Now, normally we go through each individual storm and show the impacts, but due to the vast number of storms that did hit the U.S., we just have a summary slide here on the right. All of the named storms that did impact the United States or made landfalls are shown along with the date, as well as whether they were a tropical storm or a hurricane. The names there on the left, we started out in late May with Bertha impacting the U.S., and then Tropical Storm Cristobal, and then the Tropical Storm Faye in early July. But then we started getting into the hurricanes in late July. Hannah, with maximum winds of 90 miles per hour, hit southern Texas. Isaias, Category 1 hurricane, moved up the east coast with 85-mile-an-hour winds. Then the big storm of the year, Hurricane Laura, moved into southwest Louisiana. Winds at landfall 150 miles per hour, so a lot of destruction from those intense winds as well as the storm surge. Then we had Hurricane Marco, pretty much the same time. When it did make landfall, though, it had weakened quite a bit over southeast Louisiana, only winds of 40 miles per hour. Then Hurricane Sally in mid-September, 105-mile-an-hour winds with that system as it moved into southwest Alabama. And then Tropical Storm Beta, and then a Category 4 Hurricane Delta. That one in early October did also move into southwestern Louisiana. Pretty active year with 5 systems moving into southern Louisiana. And then we kept going into late October. Hurricane Zeta moved in with 110-mile-an-hour wind gusts in southern Louisiana. And then late in the season, Hurricane Eta um, with 50-mile-an-hour winds at one point of landfall in Florida, and then 65 at another landfall point. So quite a bit of activity. This is just another way of looking at the impacts. The colored map on the right shows the warnings and watches that were put out. The yellow indicates tropical storm warnings, so mainly for wind gusts of tropical storm intensity. And storm surge would be in the brighter pink color showing up. So basically, most of the impacts were along the coastal areas, but the wind impacts did streak inland with a number of these systems. And Isaias was the storm along the east coast that resulted in a lot of wind impacts moving all the way up into southern New England. Costliest storm of the year was Hurricane Laura with $19.1 billion in damage from that particular system. So that was a quick rundown of 2020. We just like to keep an eye on long-term trends in terms of hurricane landfalls for the U.S. This was from research done a few years ago, but it shows that generally we've had a slight decrease in landfalling hurricanes between 1900 and 2017. There were some quiet years in there between 2006 and 2015. And then, more importantly, the major hurricanes making landfall in the U.S., they were occurring at a pretty regular clip, but between 2006 and 2017, there were no major hurricanes that made a landfall in the U.S. So we're coming off of a really quiet period in recent 10, 15 years. So last year was quite a change, kind of a reversion to the mean, trying to make up for those quiet years. Another item we like to point out is that it's not just the storm surge and wind associated with tropical cyclones, but extreme rainfall is a pretty serious issue. This map shows the record rainfalls from a tropical cyclone for each of the states. So you can see that amounts of 60 inches have occurred in Texas, and in fact in recent years, but many areas seeing 10, 20, 30 plus inches from an individual tropical cyclone. So very impactful results can occur with flooding. So just summarizing some of the important historical factors, we did have that period of fewer landfalls that occurred in the past decade. Between about 2008 and 2018 was much lower compared to the last 150 years. So statistically, we had a pretty quiet time. And as I mentioned, we had no major hurricanes make a landfall between late 2005 and 2017. That was a record span. Since then, we have had 4 major hurricanes make a landfall. And it's important to remember that an impacts from a storm of of sufficient intensity located in exactly the wrong spot can cause some pretty significant disruptions and be quite a major event. Some examples of that would be Superstorm Sandy and Hurricane Harvey. And if landfalls and intensities catch up with some of these historical patterns, the costs are going to be much greater due to growth in exposure, vulnerability, and wealth. Cities have really expanded, and we've got a lot more property and infrastructure. So possibility of intersecting a hurricane with some of these more costly areas, that threat continues to increase. And we're also seeing some evidence for a recent trend anyway in the last 10 years or so for storms to slow down or stall once they approach the North American coastal areas, and that has led to some higher rainfall totals. So again, keep in mind the flooding is a big part of systems, and the flooding can extend well inland. So that's a quick rundown of last year's historic events and a bit of a historical perspective on storm systems. And now let's take a look at the upcoming season. Nathan Hamlin will provide you with that information. Take it away, Nate.
Very much, Jeff. And then that historical information does put a lot of context into the upcoming forecast that we're about to deliver. Well, let's first take a look at the seasonal averages. They have been updated. A new climatology has come in. So on the left, you'll see what the 1981 to 2010 climatology in terms of named storms, hurricanes and major hurricanes, 12, 6, and 3 respectively. The updated climatology from 1991 to 2020 goes with 14 named storms, 7 hurricanes, 3 major hurricanes. So averages, we'll be comparing to those new averages when we say if there will be an above normal, near normal, or below normal hurricane season. So let's take a look at some important seasonal factors when it comes to tropical development. And this is enhanced when you have warmer ocean temperatures than average. So think of it as greater fuel for storms to work with. Vertical wind shear change with height. So if the winds are blowing the same direction and the same speed at the surface and way up aloft, these storms have a tendency to become more organized and stronger. And if there's a lot of change in winds with height, then the storms tend to be stretched out and less organized. So we want less vertical wind shear, similar winds aloft for storm development. And if you have large scale rising air motion around the area, that definitely helps. So those three things together can make for a explosive storm development if they're all present. And let's take a look at some favorable hurricane season conditions in the main development region. And the main development region is defined from west coast of Africa along the tropical Atlantic all the way to the Caribbean Sea, where all that red color is. And you can think of it as this. If you have a stronger and wetter West African monsoon, that tends to spit more tropical waves westward out into the Atlantic. And if the Atlantic has those conditions that we just talked about present, any one of those waves will be able to develop into an organized tropical system. So we want, of course, warmer ocean and reduced wind shear in those areas to create tropical storms. Let's go look at the seasonal forecast now. And as usual, we want to look at the seasonal drivers to see what will steer the season one way or the other. And usually Enso is first thing we look at. And if you look at water temperature profile on the map on the right, in the tropical Pacific between just west of South America, and you can see there's a mix of things. You see some cool, some warmth. So we have neutral Enso conditions through the summertime and into the fall. And that is a change from the La Nina that we're coming out of. And we have a negative phase of the PDO, and what that means is all that warmth in the North Pacific south of Alaska is in place, and west of that. However, if you look at right along the immediate west coast of the US, you have cooler water. So that combination creates a negative phase of the PDO. And the AMO, which is basically a measure of water temperatures in the Atlantic, you see lots of warm water in the Atlantic, that's a positive AMO phase. So what we like to do is look back in the past is years that had similar ocean temperature profiles, and that can give us some clues on where the long-range weather pattern is going. Let's take a look at the Enso. It's one of the most important things that we talk about. So let's see where it's going here through the summer and into the fall. And what you're seeing is the average water temperature all in the Enso region from modeling centers all across the world. So all different models being run here. And the thick red line you see is the average. And to be an El Nino, you want the sea surface temperature anomaly to be 0.5 degrees Celsius or warmer. And if you want a La Nina, you want minus 0.5 degrees Celsius or cooler. And you can see there's a pretty good consensus that everything will be in the neutral range. Very little chance of El Nino or La Nina all the way through the summer and the fall. And why does Enso matter? Well, this table here can tell you a lot. So focusing on everything on this table since 1995, all years, 15 named storms since 1995, 7 hurricanes, 3 majors. However, if you have El Nino years, although since 95, you have less. So you have 11, 5, and 2. And if you have neutral or La Nina, those are more indicative of active conditions above the all years average, 16 named storms for both. And it's pretty similar for neutral or La Nina, just a slight tendency for La Nina to just have more hurricanes. So neutral and La Nina tends to lean towards a more active season. And since we have neutral conditions, that factor points towards a more active season. So let's take a look at some analogs that we talked about, average weather conditions from previous years with similar ocean temperature profiles that are expected this year. And what you see here are the top 6 analog years, 2001, 2012, 2008, 2013, 1996, 1989. And the first thing that stands out to me is that there are pretty active seasons mixed in there, at least especially the modern ones, 1996, 1989, maybe slightly less. And another thing that stands out is you see the number of storms that are able to recurve and go out to sea. So you see they start going west, then they turn north, and then they turn east before they can reach the East Coast. It's not a universal signal, but there is a bit of a signal that shows the number of storms doing that. So it gives you at least an average or a below average U.S. landfall threat for many of those years, even though many of those years at least have one. Taking an average here, the 1991 to 2020 historical average, as stated earlier, 14, 7, and 3 for named storms, hurricanes, and major hurricanes. In 1995 plus neutral years, the average is 16, 8, and 4. So neutral again gives you a little more enhanced threat than the all-time average. And the analog average here is slightly above the historical average, 14.7, 7.5, and 3.2. So the analogs point towards a somewhat more active year than normal. Current sea surface temperature anomalies here, just to kind of put a point on it here. It shows all those things going on right now that we're expecting in the summertime from the forecast, but call your attention to all that warm water across the Atlantic Ocean and the tropical regions and across the Gulf of Mexico and areas off the southeast coast. So if that holds up and remains that way, that is definitely a sign towards more active conditions. Let's take a look at some model guidance here. Tropical parameters, so as noted here on the map on the left, warmer Gulf and Atlantic Ocean temperatures, as the CFS model sees it, will be in place, all those oranges and yellows. And on the right, we look at the wind shear, where you see the blues, that is below normal wind shear, the oranges are above normal. And it's a very ominous sign when you see all that blue all across the tropical Atlantic through the Gulf of Mexico and off the southeast coast. So that is definitely a favorable aspect for a more active season. The rainfall forecast from the European model, and it does have reduced rainfall in the southern Atlantic and the western Gulf, a little bit more in the central Atlantic. You can see some of the greens and stuff pop up there. So it does have a reduced Caribbean threat, but this model, just to be honest here, has a little bit of a dry bias in that part of the tropics. So there's something to keep in mind, but it does not have the dry bias right up along the Gulf Coast and in the southeast. So you can kind of see hints of stuff going on out there. So let's take a look at upper air patterns, since they tend to steer where these storms go. We can get a kind of a clue on whether we'll have an active landfall season. And the period Jeff talked about, 2006 to 2016, there was a reduced rainfall period, and a large part of the reason why that was that there was a mean trough that set up in the east, right along the east coast of the United States, maybe just inland, denoted by that L and the little blue colors there, and air flows counterclockwise around that. So any storm that tried to form in the main development region and come westward, the trough picked it up, turned it to the north, and then eventually turned it to the east. And it acted as kind of a barrier to keeping many of these storms out to sea. Let's compare that to what happened last year, 2020. See a different pattern. The trough is pushed way inland and a big low pressure area across Canada, and you had the high pressure right along and off the east coast. When the storms were able to come west, the high pressure actually blocked them from coming northward. And then the trough across the central part of the country was able to pick them up, steer them northward, and bring them into the Gulf of Mexico. And that contributed in large part to the very active landfall season we had in the Gulf of Mexico. So let's compare that to what the analogs have to say for this year. Well, this is kind of a hybrid. On the one hand, there's that familiar looking trough along the eastern coast, and air should flow again counterclockwise around that. So when storms come east, they should be picked up and sent to the north. That is a good protector for the Gulf of Mexico. That's an unfavorable aspect for landfalls there. However, that high pressure system it's a little bit further east per se, but it's still just off the Canadian Maritime. So when the storms come north, they're going to be blocked from being able to be pushed to the east because that high pressure is in the way. You can't move it out of the way, and the storms can't go through it. So it'll be steered northward. So that's more of a favorable pattern for right along the east coast and the northeast part of the country. So this is something that we'll have to be mindful of as we go through this season. Even though we'll get the recurving storms, doesn't mean they're actually going to recurve and go off to the east harmlessly. So let's put all that together in terms of a tropical outlook, and we're going to go for another active season, 20 named storms in all, 9 of which should be hurricanes, and 4 of those hurricanes should be major. So we're going to go with an active season. It pales in comparison to last year. It's not going to be as active as last year, but it is going to be more active than normal. In the areas, because of the steering flow we just mentioned, we think the East Coast and Florida to maybe South Carolina and then up towards northeast and into the Canadian Maritimes. Those are areas that will have to be watched. Now, put a little perspective into the northeast and the Canadian Maritimes. You usually get a hurricane landfall up there every about 13 years or so. It doesn't happen all that often. So even though it is more elevated than normal, doesn't mean that you can expect one. It's still a lower probability, but if there's going to be a year, this will be one to watch for a hurricane landfall. So that's the perspective you want to reach on that one. On the other hand, the western Gulf of Mexico through the western Caribbean, we think will have reduced risk versus normal. To keep everything in mind, all it takes is one storm in a bad spot, and even if it's very few storms out there, if that happens, it's going to be thought of as an active season, and it could be a very high impact. Here is the quick list of storm names here. We have A through W, and if we happen to sneak through that, we do have a supplemental list that we could use. So let's go for the key messages. Conditions appear favorable for another more active season in the Atlantic, and model guidance shows warmer than normal water temperatures and reduced wind shear, both of which would be supportive of more tropical cyclone activity. And our analog upper air steering patterns show that Atlantic storms would be more favored to impact the northeast U.S. and the Florida region with reduced risk for the western Gulf. The caveat there, though, is even a weaker tropical system can have significant impacts if it strikes a more vulnerable location or it moves slow. So again, we have to keep, even if it's a reduced impact type of season, we have to, all it takes is one, and it could be very, very memorable. With that in mind, I'm going to pass the baton over to Steve Strum, who's going to tell us all about the summer forecast highlights. Take it away, Steve.
All right, thanks, Nate, for taking us through the tropical season forecast. Now we'll kind of take a look at some other aspects of the forecast for this upcoming summer, namely temperature, precip, and some other related impacts. So starting off here, looking at the temperature outlook for the heart of the summer season, the June through August time period, we are once again looking to see most of the country coming in warmer than normal. Now note these are still these forecast maps are still relative to the 1981 to 2020 normals, although even with the newer normals, they would still show a warmer than normal pattern for most areas. But you can kind of see that the main focus for the warmth, once we get past June, looks to be across the western half of the country. So pretty much the plains and Rockies look to see the strongest warm anomalies as we head through July and August. And areas farther east may average a little bit closer to normal. However, the caveat there will be that we will likely see higher humidity levels across the eastern U.S. this year, in part also some related to some additional rainfall. And so the lower intensity of the warmth across eastern U.S. will be at least partially offset by the higher humidity and higher heat indices that we may see in those areas during a good portion of the summer season. Now, looking at rainfall, we do look to see the wet pattern we have in place this week across the plains kind of continue going forward here into June. So a lot of the central U.S. will likely average at or above normal in rainfall for the next month or so. And then we could see that region transition to a little bit of a drier pattern as we head towards the middle of the summer, with increased risks for heavier rainfall kind of shifting towards the southeastern U.S. So really the Gulf Coast and East Coast could see higher than average rainfall at times during July and August and possibly beyond as well. Although a lot of that will depend in part on exactly where tropical systems may potentially impact the coasts during the course of the summer and early fall. Obviously, any area that does get impacted by a tropical storm or hurricane, especially a slow moving one, could see some very heavy rainfall. And so you may see some localized pockets of extreme rainfall anomalies wherever any tropical system tends to track across the eastern U.S. this summer and early fall. But overall, the pattern should still generally favor a lot of areas staying kind of near to above normal in rainfall in those areas during the course of the summer season. Now, looking at the severe weather pattern so far, it has been a little bit quieter than average so far. We've had some bursts of severe weather activity, but we kind of had a late start to the season with some colder weather there in February and at times during the spring. And so we have not really seen a real active pattern get going so far, but we are going to be seeing more severe weather here the next couple of weeks. And so we should get a little bit closer to that normal line, which is that black line on the plot on the right-hand side there, which is kind of the average of the last decade or so. And so we are looking to see sort of an uptick here going forward. And we still are not out of the woods by any means in terms of severe weather. Typically, we do see severe weather peak during the month of May, usually late May. So around Memorial Day is typically kind of a historical peak in severe weather. And activity typically stays very elevated during June, but then tapers off during July and August. So we still have another month or so to go in terms of the very active part of the severe weather season. And as we head towards July and August, typically we see the overall frequency of severe weather decline and also shift northward. We typically see more severe weather events across the northern tier of the country during the second half of the summer season, with less activity across the south outside of hurricane impacts. Now, looking at some other impacts for the summer season with the forecast, kind of looking at the aviation impacts and some other things here. Starting off looking at the jet stream anomalies forecast for this summer season, we look to see overall potential for some higher than average winds at jet stream level from the northwestern U.S. Kind of southeastward towards the Carolinas, with somewhat weaker winds across the Great Lakes and Northeast and across the Southwest. So that will have some impacts on air travel going forward during the summer season in terms of fuel efficiency and so forth. Looking at thunderstorm potential this summer, right now we are seeing an elevated risk for a lot of severe weather activity, thunderstorms in general across the Plains region, parts of the Midwest as well here for the upcoming couple of weeks. But as we transition towards kind of from beyond mid-June and through the rest of the summer season, we should see less thunderstorm activity across parts of the central U.S. So the Corn Belt in particular could be a little bit quieter this summer in terms of thunderstorm activity. However, that will also have impacts on terms of possible drought development in those areas going forward. However, the southeastern U.S. could see more thunderstorm activity in general as we head through the summer season. Obviously, some of that could be tied to tropical activity as well across those areas, especially towards the latter half of the summer season. As we look at turbulence for the summer, we could see a higher than average risk and higher and more frequent risk for higher turbulence levels across the central U.S. in general. So that will also have some aviation impacts as we go through the course of the summer season, especially across those middle portions of the country. Now, I mentioned drought a little bit earlier. We do already have significant drought in place across a large portion of the western half of the country. The map on the left kind of shows the existing areas of drought. Note that there is some drought as well that's kind of extended eastward across portions of the Corn Belt towards the Great Lakes. It's been quite dry in some of those areas, however, that's been mitigated by cooler weather as well. So the cooler temperatures have kind of slowed plant growth and have also slowed evaporation rates. So drought has not really gotten too severe at this point in time across the Corn Belt, but certainly as we get warmer, if the drier trends in those areas continue, we could see some expansion and intensity of the drought there. But across the western U.S., very high probability of drought being in place all summer long, and likely an expansion of that area of drought across the west and an increase in the overall severity of it in many areas as well. So of course that will have an impact on the fire weather season across the western U.S. as we head through the summer as well, with certainly very elevated risks for fire conditions across a lot of the western U.S. So that kind of summarizes things here on this chart, with the West Coast and the western U.S. in general mostly averaging above normal, but again, with that drought in place and the dry conditions forecast to continue across that area in most areas, we are going to be looking at certainly an expansion of drought and a heightened risk for wildfires across most of the western half of the country. Again, some of that drought could expand eastward across portions of the central U.S. as well as we had through the summer season. But across the southern and eastern U.S., again, we are going to be looking at warmth that will be somewhat less intense in areas farther west, along with elevated chances for above normal rainfall across, especially the southeastern U.S. And again, anywhere along the East Coast that does see a tropical system make landfall, we'll certainly see a lot of rainfall from that, and that may boost their seasonal totals to above normal levels as well. So certainly those areas will have the best probability for heavier rainfalls once we get past the next month or so. And certainly from the Midwest westward, those areas will be looking at the potential for expansion of drought and the higher overall temperatures during the course of the summer season. So now at this point in time, you should be seeing a poll pop up on the right-hand side or somewhere on your screen. So please take a minute to answer those questions there before we kind of progress on to the remainder of the presentation here. So next up, we're going to have Ryan Fulton, and he's going to start taking us through some of the potential offshore impacts that we could be seeing from this hurricane season. So Ryan, pass you the ball here and go ahead and take it away.
Alrighty, thanks, Steve. All right, so yeah, we're going to take a moment here to connect some of the information that we've seen so far with impacts within our marine industries and coastal industries. First of all, I'd like to start that over the last 6 years, we've had this interesting situation where a storm has formed typically as early as late April, but in other times around mid-May. And this year does look like it might break that streak. All the long-range models over the next couple of weeks do look very, very clear in terms of any formation. All of the conditions that are necessary for a tropical cyclone to form are really not in place. It looks more favorable that something that would be that first storm this season would be more the first week or two of June. So it does look like we might see an end to that streak. Much more favorable that we will see an end than we won't. And then as we've seen, the conditions are favorable for an enhanced season. We're forecasting there are 20 named storms for the season, but the steering pattern is definitely an interesting one, especially for customers and operators that are in the Gulf region. Last year was a very difficult year with a large number of storms making their way into the Gulf of Mexico and into the Western Gulf. So having that steering pattern, that blocking mechanism, that trough digging down the East Coast, it's not going to be perfectly consistent throughout the entire season. There's still the chance that a storm could propagate through the Caribbean Sea and into the Gulf. But it is still a very good piece of news there that the pattern is in place to steer some more of these storms out to sea. And that's good news for the Gulf. But then we had the flip side of it, that there's also an interesting pattern set up to where the northeast coast could potentially see a storm that may otherwise be redirected out to sea. So that's certainly worth noting if you're along the east coast. And then finally, some of those notes there that Stephen was covering on thunderstorm activity. We see those increased risks, and specifically as you move into July and August with those increased precipitation chances over normal, that would apply for folks on the East Coast to keep an eye out for. So shifting back from thunderstorms over to tropical, it's good to review what our existing customers have at their disposal to mitigate these impacts, and also for any potential customers that would want to consider some of these tropical decision support tools that we have available. So our offshore customers are going to have this included with their services, and then if you are perhaps a utility or a Department of Transportation, et cetera, that's on the land-based side, this is a service that you could have added onto your services from DTN. So these advisory services that we provide to our customers are based on a tiered system where on a day in and day out basis we provide an overview of what's expected over the next 7 days, and then twice per week we'll even provide a 2-week extended outlook. And then as systems start to get more serious, we engage the next level of reporting. And it's actually quite good to walk through a case example to kind of illustrate how this works a little bit more clearly. So we'll take Hurricane Delta from last year. This was a tropical wave that propagated through that main development region that we were talking about here about 20 minutes ago. And it officially formed as a named system on October 4th, dissipated on the 12th after it made landfall in Louisiana. And this was a kind of an unfortunate follow-up storm to Hurricane Laura that provided quite a bit of devastation there to western Louisiana. So with this particular system, we start with that 2-week or 15-day long-range extended outlook, and this was indicating at the end of September that there was an enhanced risk for formation of a tropical cyclone in the Caribbean Sea region. So that was about a week before the system actually formed. And then we started seeing when it was just a kind of a puff of clouds, tropical wave, that started on 30th of September, identifying that this was a tropical wave that had a specific potential for formation. And so on the daily tropical planning report, we have a single page dedicated very specifically to this threat. And our forecasters would provide a briefing of what they're seeing with the probabilities for formation and what are those influences going to be, also on a potential track should this get its act together and form. And then once it reaches a minimum threshold, we begin issuing significant tropical disturbance advisories. And so we typically issue these many days or hours ahead of even the National Hurricane Center's potential tropical cyclone advisories. And so our average for the 2020 season was 38 hours before NHC started issuing those bulletins. We were issuing these reports. And it is effectively a hurricane track forecast, the same type of track forecast you would see for an official named storm, but we are giving that guidance for a tropical wave that has a strong potential for forming into a cyclone. So our forecasters detail that information and provide that initial track. And then we continue to issue these reports up through the point where it is classified as a tropical depression. So that happened on October 4th. And this would be an example of one of those active storm advisory reports. And at this point, our forecasters detail a great deal more of additional kind of consultative information. So if you have offshore operations, what kind of marine weather impacts that you're going to see. Oh, apologies. What kind of, I need to use the arrow thing. What kind of marine weather impacts you're going to see, or if you are on the coast, what kind of onshore impacts you're going to see. And then finally, a thorough briefing on what's influencing the intensity, the track, and other variables that are worth considering for this particular storm. So keep moving on here. And then so that these are effectively macro level reports giving you that high level understanding of what the storm is going to be doing, what track it's going to be taking, etc. And then we take it a step further where the customers that are located either offshore or onshore are then using these site-specific reports. So a T-time report is heavily used for offshore, and it's giving you basically a countdown, utilizing your time-based thresholds. So if you need to have a platform evacuated 48 hours before the arrival of gale force winds, that's what's used as your T-time, and it gives you the countdown of time remaining until that point. Or if you are on a land-based location, more typically we provide a threat report, which gives information like wind speeds broken down hour by hour for the entire event at your location, expected storm surge, precipitation, all those different threats encompassed in there. And then finally, another type of site-specific report that will generate is a risk and response report. These are geared towards operators that like to use a staged emergency response criteria. So, if the storm is within a certain distance or a certain time from reaching your site-specific location, and you have, say a rule at 96 hours and then a different rule at 72, etc., you can actually program those rules into this tool, and the report that's generated will tell you whether you've reached that particular stage and then how much time you have left before reaching those particular thresholds. So it's very useful for anyone that's operating on a multi-stage progression. And then finally, wanted to also share that all of the same information we make available through ArcGIS data services for customers that operate a great deal of their emergency response systems on the Esri ArcGIS platform. So these are tracks and model tracks and different layers that you can consume and build right within your own in-house applications. And then in addition to those layers, we can expose all the reports that we just talked about through an API. So you can then expose those reports directly inside of your application rather than relying on, say, email or access to our portal. We can deliver those reports right within this experience. That's something that a number of our customers have accomplished and used, and have really gotten a lot of benefit out of centralizing their entire emergency response system and using Esri ArcGIS. And so at this point, I'll hand it over to Ben, and I'll look out for any questions that anyone has on the marine side, and we'll come back to that in the Q&A.
All right. Thanks, Ryan. And this is Ben Hershey. And I'm going to go over some of the transportation impacts that we may expect over the next few months, given the tropical update that we were just presented with. So some of the things that we're going to cover in this section is what are some of the key messages that we can take out of the tropical update and our summer update for transportation and the impacts that may be encountered. And what are some of those challenges that we expect based on the opportunity of having some storms move into the land and impact our areas, and then maybe some of the other issues that we might expect. And then what are some of the solutions that we do provide? And Ryan gave a great overview of some of those examples of some of the tools that we provide to customers both offshore and right onshore, but what are some of those other information aspects that we can provide for our transportation customers? So if we look at those key messages, and again, we want to make sure we're reiterating those from our long range forecasters, and we really appreciate all the work that they've done to pull that together. We are looking at that neutral pattern, and what that means is we could see some elevated risk for some tropical storms, and depending on where they occur, they may occur in areas that are maybe not as traditional, or what we saw last year, or we might see some more impact to our mid-Atlantic and Northeast customers on the transportation side. And when we think about that, the population centers are great there as well. And so what are those impacts of being able to move people on land given a storm event that may impact those areas? And we are looking at potentially some wetter conditions across the eastern U.S. And so in those situations where we have already saturated soils from thunderstorms that may have occurred only a few days before any type of tropical weather that may move in, that's going to impact the soils and the areas that are already saturated. So now we need to look at those increased flooding risks, where you already have flooding situations ongoing, and then you add in tropical weather onto that. That's going to put a strong stress on the transportation infrastructure of being able to move people and goods. And also, we don't want to forget about the situation that we are dealing with across the western U.S. And then that point is we have some very dry conditions, and we might have some fire weather situations to deal with. And that does impact our transportation customers of being able to help out with the firefighting efforts. So what are some of those impacts if we do have, looking at that elevated risk of tropical weather? Is crew scheduling and reallocation of staff. And so we know that a lot of our DOT partners are looking at that information, and they will move crews from one area of a state to another to station to be prepared for the pre-storm, the during storm activities, and a lot of it is the after storm activities that need to occur for opening up roads, working with other groups out there, utility companies, things like that, to make sure that the infrastructure is safe. Closing roads due to debris or flooding potential, as the image shows there, is making sure that the crews are out there. If it's DOTs down to the cities and counties, making sure that we're trying to inform the public of roadways that have been impacted in this situation here. Obviously, putting some type of messaging out there that you do not want to travel through that roadway, and now it becomes a safety hazard for people traveling. And then all of the agency coordination. And when we look at tropical weather events, because we know that the weather is generally going to be moving in, it's different than maybe the thunderstorms that are a little bit more unpredictable. When you know what a tropical weather system is going to be moving in, there's a lot of agency coordination, discussion between interagencies of who's doing what, how are we handling things. Also, for those that have coastal areas, is making sure that they're aware of their impact on those transportation infrastructures, shutting down bridges, shutting down tunnels that may occur in certain areas, and knowing what those criteria are and having up-to-date weather information to be able to provide that. And then as we look at the drought conditions, again, out west, we may have to deal with, for some of the cities and counties and DOTs, dealing with road closures based on firefighting efforts, and just assisting with other groups that are out there trying to move infrastructure from A to B to make sure that we're keeping people safe, and also in those firefighting situations. So as we look at tropical weather in the transportation space, and Ryan did an excellent job of showing a specific case study, I'm going to take a little bit more of a generic approach of how we approach it on the transportation side, and some of the information we can have to help you all make those decisions. So when we look at before arrival, a lot of information is being communicated, and that communication is huge, both inter-department, so being able to move crews around, but also outside of the individual departments, if it's cities or counties working together, or the counties in the states states working together and making sure that they're all on the same page of how they're going to handle infrastructure things. You know, when they have to start moving people out of areas and contraflow traffic of shutting down an interstate and having both sides of the highway going in the same direction, that takes an incredible amount of communication, and being able to decide when that's going to happen is critical on what the weather is going to do to that individual area. And then again, as you know, some of the resource allocation and the mitigation actions, shutting bridges down, shutting tunnels down based on the impact of the storm event. And then during the event as well as just understanding what is currently going on. What are the current conditions? What is the short-term forecast? Where is that system going to move to along on the coast? Managing expectations. You know, there's one thing that we can't do is we can't stop the weather from occurring. So what are some of those expectations, and how do we provide that information? And then supporting the utilities, making sure that power is staying up. And if it's not, how does the transportation infrastructure help with that? And then obviously after storm is assessing those key pieces of infrastructure, bridges, tunnels, things like that that may be impacted by wind, but more further inland. You know, we deal with a lot of issues, and we hear about the issues on the coastline, but there's a lot of weather that occurs from these tropical events that happens much farther inland that can impact those different infrastructures. So again, assessing those not just along the coast, but further inland. Getting that short-term forecast. And you know, when we look at the transportation infrastructure, a lot of times, even in the wintertime, we hear the question is, what's going to happen next, right? And so having that short and mid-range forecast of over the next 7 to 10 days is really critical for making decisions about what to do, where to move your crews back to their home location, or do they need to stay in that outpost and deal with issues that you have in the infrastructure. So again, the consultation side of it, and Ryan had showed that on the tropical side, but also within the transportation Weather Century Online and our ClearPath weather products, is the ability of getting that consultation from a forecaster and providing updates. And then, for example, the screen share here on the left is actually from Hurricane Sandy, and really getting a sense of what is that impact to the transportation space based on that storm event. And so having that direct communication with our team of meteorologists is valuable in making those decisions. Again, the planning, you know, we have the ability of integrating a lot of the federal data, so the National Hurricane Center data here in the United States, and then looking at what those impacts are. So from flooding, the wind impacts, the severe weather potential, and the duration, and then the after storm weather. So looking at all of those and having that integrated in one platform of being able to see not only where the tropical weather is doing, but what is the other weather doing? What is the severe weather going to do? Is that cold front going to come into the coastline, or is it going to stay further inland? How is that going to impact the weather, not just in that coastal areas, but further inland that may impact the transportation infrastructure? So one of the ways of doing that is through the daily planner that is available to our transportation customers, of getting that user customized information. Can be sent multiple times, and it can be sent to multiple different users through email, and it highlights different areas. So what is the precipitation going to be? You know, what are the temperatures going to be? All those type of things. The wind speed is really critical for those decision-making activities. Again, that in-storm operation, obviously the radar data, one of the things that we talk about a lot in transportation and in most industries, you know, everyone wants to see what the radar looks like right now. So having both a mosaic and the single site radar information integrated right into the interface, the real-time storm reports, and obviously the real-time observations of what's currently going on. What are my wind speeds in this location? Do I need to start to move resources or move them out of there or move them into an area? Updated camera imagery is possible, that updated forecast, and obviously the continued consultation during the event itself. That local radar data, which is integrated within the applications of Weather Century Online and ClearPath Weather, are key for our transportation officials to be able to see what's going on. And so this local radar data is then that heightened information, giving both the reflectivity, so the intensity of the precipitation, but also the wind speed that may be occurring at that location. And then the real-time alerting integration. So taking the information that not only we are providing, but also bringing the information from, let's say, the National Weather Service or the National Hurricane Center into one individual location, so you're not having to go to multiple web pages, is a critical aspect of the solutions that we can provide. And the severe weather alerting. So one of the things it gets forgotten about when we talk about tropical weather situations is what happens inland. And we see a lot of, while not F4 and F5 size tornadoes, not the huge tornadoes that you may experience across Oklahoma and Texas, but we see a lot of smaller, quick spin up tornadoes that occur with these tropical weather events as they make their way on shore. And so having information to be able to send right to your phone, to your email, giving you an idea of when you may expect that impact of that tropical or that severe weather to occur on land is critical for, again, your transportation operations. And again, one last thing to reiterate is that long storm or that post-storm forecast, giving an idea of doing some long-range planning. For example, in the image here, you're going to be out there for a while and dealing with some of the infrastructure that has been damaged based on that storm event. Understanding what is that forecast for the next 5 to 7 days, and in the case of here, the images, we're looking at nice weather, so that allows you to be able to catch up on that. But if we have a situation where all of a sudden you're going to expect another round of thunderstorms coming from the Ohio River Valley or other areas in the U.S., that could then change how you attack your transportation infrastructure activities. And one last item, we do want to mention the fire weather situation. We do provide information and weather data to help our transportation crews understand where they may have heightened risks. So we're looking at relative humidities and wind speed, and also integrating some of the fire weather information that's provided by the other agencies into one platform to help with understanding, wind speed, wind direction in those situations where we start to have fire situations. And we expect that to occur across the Western U.S. again this summer. And we want to make sure that you recognize that that DTN has some of the products to help with moving your transportation crews if you have issues in certain areas. So with that, I'm going to turn this presentation over to Wes, and Wes will cover some of the impacts on the aviation side. So Wes, here you go.
Thanks so much, Ben, and good day to everybody on the call. Thanks for sticking with us here. As Ben mentioned, I'm the Senior Product Manager for the Aviation Marketplace here at DTN, and today, similar to Ben, I'll be speaking about the operational impacts and what we can do to mitigate those risks for aviation. So you heard Steve and Nate talk about the outlook here. So what does this mean for aviation, right? We talked about more frequent thunderstorms across parts of the Southeast and Mid-Atlantic. Steve mentioned the increased turbulence potential over the central and southern plains. Nate talked about the elevated tropical threat in the Southeast and New England. And then you also heard Steve talk about the warmer than average readings across the entire U.S. for the upcoming summer, particularly in the Western United States. So from an aviation point of view, those thunderstorms and severe weather, when we think about what that means to the impacts on our marketplace, it's really about contingency planning and how that's going to impact our operations, our airport, or at our airline. So anticipating the ramp closures and reopening the ramp safely, keeping our assets, most notably our people, safe from thunderstorms or severe weather, and also passengers and other key members of the operation. So the primary way we do this is through Aviation Sentry. This is our software service that we provide here at DTN, and it's a website portal here. This is just a snapshot from earlier this week, where you can get real-time weather information, access all of our proprietary aviation content, access our team of aviation meteorologists 24/7, receive customized alerts, and also this tool is available in multiple languages. One of the key aspects I like of Aviation Sentry is how you can set up an alert to understand when a storm is going to impact your location. So in this example here, I've set up a example for a given airport out ahead of a squall line here, and you can see the time countdown. We call it the estimated time of arrival for the storm cell to arrive at your location. So this helps you understand how much time you have to clear the ramp, get people to safety, secure your assets, and lock things down before the severe weather occurs. You heard Ben also mention the alerting aspect of things, and one of the great features within Aviation Sentry and Weather Sentry is the ability to set custom alerts really specific to your organization. So the tool offers the ability to have an action message set for each specific severe weather parameter that you'd like to be notified about. This includes lightning or any severe weather potential related to possibly hail or tornado. And if you have a standard operating procedure at your airport or within your airline to take a certain action, you can input that message into the software, and it will then alert you and all the recipients that you desire to have that information when the threshold is breached. And one of the great things about this tool is the accuracy of some of the data sets. This is a example from a couple years ago down in Fort Lauderdale. The lightning actually struck the runway, and this shows the accuracy within Weather Century of the actual lightning strike. It plotted the strike right on the runway, and you can see the picture there in the upper part of the screen, which damaged the runway itself. So that gives you an idea of how hyper local this system really is when it comes to the alerting capabilities. Moving on to the turbulence, it's all about routing here, what kind of fuel savings we can have, reducing our carbon footprint. Again, maintaining the asset's integrity, right? When severe turbulence occurs, we have to take it out of operations and have it inspected for quality assurance purposes. Keeping our passengers and our crew, our employees, safe inside the aircraft, and of course, finally, we want to stay out of the media. When there's big turbulence events, people are injured, that gets in the media spotlight, and that's not a good thing for anybody. So in the summertime, we're concerned about turbulence, but in a different manner. It's usually around thunderstorm, convectively induced turbulence. And this is turbulence that's close to a thunderstorm, but not in the thunderstorm. And it's related to gravity waves breaking above the storm. And unfortunately, my animation's not working here in the slide, but what you would see, this blue you see on the slide, that represents the cloud ice water concentration, and the red is turbulent areas. Now the y-axis here is from 30,000 feet to 40,000 feet. If this animation was working, what you would see is through time, red areas would highlight above the actual thunderstorm, and that's where the turbulence occurs. So I want to make it clear that flying over a thunderstorm does present a risk to an aircraft, and we need to be mindful of that as we're planning and following our flights. So the best way to track that and anticipate that is DTN's Rapid Update Turbulence Forecast. This is as I mentioned, rapidly updating forecast. Every 10 minutes, we're creating a new global forecast of where we expect convectively induced turbulence to be occurring. Today, we have 22 different flight levels where this occurs, so you can understand with confidence where you can operate in and around thunderstorms, above a thunderstorm, above the threshold that the turbulence might be possible. We talked a lot about tropical cyclones from the aviation side of the house. It's really about, removing aircraft out of the cyclone's path so they can avoid damage, right? And then just as soon as the storm departs, getting the aircraft back into the airport that was impacted so it can resume operations safely. Another key impact related to tropical cyclones is the safety of our personnel. We want to get those employees out of harm's way and then position them back to reopen our operation. And then finally, when do we close the airport and get the on-site equipment removed? And this image here is a classic image from Hurricane Sandy back in 2012. This is LaGuardia Airport. The flooding that occurred at the airport there was just tremendous. So I'm not going to go into detail. Ryan did a fantastic job talking about all the tropical products in the aviation world. This same content can be leveraged for your operation, and I'm not going to go any deeper into that based on the job that Ryan did. Lastly, I'd like to talk about heat. With the summertime, Steve mentioned all the excess heat across the United States that we expect, and that impacts us in the aviation side from two areas: takeoff aircraft performance, and then also the safety of our workers on the ramp. One way to combat that is understanding the density altitude for a given location. So as air density decreases from elevation or increasing temperature, density altitude increases, and what that does is results in lower aircraft performance. So Aviation Century provides a snapshot of what the density altitude is in time, so you can understand how you might have performance implications on your aircraft in high heat situations. What I'd really like to talk about is heat stress on our ramp workers at an airport. So typically we've talked about heat stress. You might hear heat index used a lot, and that's a combination of air temperature and relative humidity to really determine the perceived temperature on what it feels like to a human being. But more and more in the industry, we're starting to see the use of what's called the wet bulb globe temperature as a more precise way to measure the impact of heat stress on a human. And why this is more and more common in the marketplace is because of the amount of parameters that are used in the calculation of wet bulb globe temperature. It's much more holistic than the heat index because it's measured in the sun, whereas heat index is measured in the shade. Of course, it uses temperature and relative humidity, but it also consumes items like wind speed, cloud cover, and sun angle at the time of the year to determine the impact of stress on the human. So here's an example of within Weather Century where you can understand what that wet bulb globe temperature is going to be on an hourly basis and also on a daily basis after 15 days. And there are several different categories you can utilize to understand the intensity threshold of the wet bulb globe temperature and what that means to a human. And you can see here that code black is the highest level, and measures should be taken to mitigate the risk of heat stroke on your ramp workers. So with that, that's all I had for today. Thank you for your time, and I'd like to pass things back over to Andrea for closing.
Sorry, thank you. I was on mute. Thank you all for joining us today. We do have a few questions that came in through our chat and our Q&A. So I am going to turn this over to, first I think I'm going to do Nathan to answer, I think, our first question.
All right, a couple of questions came in. We'll start with the first one. Can you give a layman's explanation of why Isaias increased in strength over land before affecting New England? I'll take this one. Most of the time when a tropical system comes inland, it typically begins to wind down and the wind field does expand a little bit, but as it weakens, the wind field decreases and the impacts decrease in terms of wind as it goes over land. However, Isaias was a little bit different because it had a trough that was off to the west. It was influencing the steering flow, so it was drawing the storm north. However, there was some blocking high pressure off to the east. So as the storm came north, it was unable to escape, and it was in the perfect timing to be able to combine forces with that trough. So usually when that happens, the trough takes the energy from the tropical system and kind of spreads it out and combines forces with that trough. So the wind field did not weaken as a result. It stayed strong going northward, and that actually spread out as a result of the interaction with the trough. And as far as New England is concerned, the reason why it was such an impact was that was certainly a part of it, but the other part of it was where the tropical storm tracked. It went a little bit further to the west. That allowed for the southerly winds to have an impact more. And usually when the wind's out of the south in New England, the trees, power lines, and things like that are more impacted. And you also get the higher risk for onshore flow, bringing in flooding and things like that. So those two factors combined allowed this storm to be more impactful than it otherwise would have. And I have another question that came in. I think Jeff can answer this one. Do sea surface temperatures favor an increased risk to close-in development?
Well, the sea surface temperatures are going to be above average just about everywhere in the Gulf and Atlantic Basin this year. So, that increases the risk from that standpoint. Typically, the early part of the tropical season, we see more close-in development occurring in the northern Gulf of Mexico or off the southeast coast. But due to that upper air pattern that Nate showed you in his part of the presentation with that low pressure trough, more dominant in the east this summer, I think that may tend to favor close-in development more in the northeastern part of the Gulf with that more westerly flow along the Gulf Coast region. And then, so we're kind of thinking the northeast Gulf through Florida and maybe the far southeast coast would be more impacted by the the close-in development type storms, which have a shorter lead time just because they pop up so close to the coast and can't track them for days on end. So that I think would be the higher risk area for this year.
Awesome. Thank you very much, Jeff. Well, and there are no other questions that I have seen come in, so pass it back to Andrea to close.
Thank you. And yes, I don't see any other questions that just came to me. So with that, we are about 9 minutes over. So I will end our session. I want to thank everybody for joining us today. Like I said in the beginning, we have recorded this session, so we will send this out to you in hopefully 1 to 2 weeks. You will get the follow-up email. We do have some administrative stuff on our end to take care of before we're able to send it out. I also want to thank our presenters, Jeff and Nate and Wes and Ben and Stephen and Ryan for all your presentations today. And with that, our next webinar will be a mid-season summer and tropical outlook update. And so that should be in early August. So look for that invite. And with that, thank you and have a great rest of your day.